Consider a beaker of boiling water in an airtight room. What will happen when a boundary is placed just above the surface of the boiling water? Will this be a closed or an open system? And now, what if the boundary is placed on the inside walls of the room? Will this be open or closed? Hey there, in this video we're going to talk about the fundamental concepts of thermodynamics. And you know what? When you grasp the fundamentals, thermodynamics is going to be easy for you like never before. I'm Stanley, welcome. But just before that, how useful is thermodynamics? A. Maximizing yields in synthetic gas companies leading to huge profits. In thermodynamics, you learn that when chemical reactions happen at equilibrium, maximum yields are produced, and that is simply how you can boost the production of ammonia gas. B. We have determining the efficiency of propulsion systems. For example, thermodynamics has shown that a methanol fuel cell is more efficient than a methanol ICE, internal combustion engine. So in your next project, be ready to use a methanol fuel cell. C. Designing batteries that can supply the required amount of voltage and current without compromising battery space. This is a huge challenge when it comes to designing electric vehicles because the battery space is limited, but the demand for voltage is high. With the knowledge of thermodynamics, you can easily go about this by designing the electrochemical cells of the battery in series with each other, therefore producing high voltages without compromising the battery space. And finally, determining whether it would be profitable for a company to synthesize a catalyst to boost the production of the main compound. If it is found out that the yield is insufficient at equilibrium without the catalyst, then synthesizing the catalyst would be useless. What about in your day-to-day life? How do you choose between electricity and gas for cooking and heating? How do you choose between a thermoflask and a water bottle? In your storage, I choose a thermoflask. It's economical. Thermodynamics is simply a branch of science that describes matter and the transformations of energy on a macroscopic scale, or the human scale. It uses variables such as pressure, temperature, and volume to describe matter. You discover that these variables can be obtained experimentally. That is why we say on a macroscopic scale or a human scale. So these variables can be obtained through experiments, can be done, can be seen, can be observed, can be analyzed. They are on a human scale. And here comes basic definitions that describe what a thermodynamic system is. A thermodynamic system is simply a system that comprises all materials that are involved in the process under study. So let's get started. Number one, we have surrounding. Surrounding is a term that is used to describe the rest of the universe apart from the thermodynamic system. So everything else, including me and you, apart from a thermodynamic system, we are the surrounding. Open system. An open system is simply a system that exchanges matter and energy with the surrounding. I got to show you guys what we mean here because I don't want any one of you to get lost. So let me tweak a few items here and there and gather some items. I'm coming. A lot has been happening in Africa, and by the way, and those electric vehicles are not going to last for long. Do you believe that? I'm back. This is an open system. Every second, every moment, some water evaporates from this cup to the surrounding, and every moment air gets diluted into this cup from the surrounding. So this is an open system. It exchanges matter and energy with the surrounding. What about a closed system? A closed system is simply a system that does not exchange matter with the surrounding, though it does exchange energy. Think of it like this. If I cover this cup, so no more water can evaporate from this cup and no more air can get into this cup, but heat and of energy can do penetrate this wall and enter into this cup. Actually, some heat is escaping from my hands into the water. So this is a closed system, a system that cannot exchange matter with the surrounding, but does exchange energy with the surrounding. But what if this system does not exchange both matter and energy with the surrounding? That is referred to as an isolated system. This is a system that cannot exchange either matter nor energy with the surrounding. Glad you know that. This brings us to boundaries. Well, boundaries are simply interfaces that do separate matter. Boundaries are simply interfaces that do separate our system from the surrounding. Think of the inside wall of this cup. It separates this water from the surrounding. Think about the walls in your room. They separate the system in your room with the surrounding. Think about the walls of a beaker. They separate the contents of the beaker from the surrounding. So boundaries are simply any interfaces between the system and the surrounding. In this case, I'm drinking water. It can help you relax and regain your energy and stimulate your brain. Boundaries can also be referred to as walls, but not all boundaries. Some boundaries are walls. For instance, the boundaries that are formed by this cup. This is a wall. Walls can be rigid, can be movable, can be permeable or impermeable. This wall is rigid, it cannot move, but the walls of a balloon, they are movable, they can expand and contract. The walls of a membrane are permeable and the walls of a polythene paper are impermeable. Note this, boundaries can be walls. Note this, walls can be boundaries, but boundaries does not have to be walls. Boundaries do play a vital role when it comes to the exchange of matter and energy between the system and the surrounding. Note this, that the system and the surrounding always want to exchange matter and energy until they attain a state of equilibrium, in this case thermoequilibrium. So what is thermoequilibrium? Thermoequilibrium is simply a state of balance between the system and the surrounding. For instance, this water is at the same temperature with the surrounding. If that is not the case, either the surrounding will lose energy to this water until it attains a state of equilibrium with the surrounding, or this water will lose energy into the surrounding until it attains a state of equilibrium. So thermoequilibrium is simply a state of equilibrium between the system and the surrounding with respect to three variables: pressure, temperature, and concentration. Boost the brain, bro. Have you seen a soap bubble just before it bursts? Have you seen a soap bubble just before it bursts? What sustains it? Equilibrium. The pressure inside the bubble and the pressure outside the bubble, the atmospheric pressure, they are at a state of equilibrium, so the bubble cannot burst. That's equilibrium due to pressure, right? So every day, every system, every surrounding, everything wants to exchange matter, everything wants to exchange energy just to attain a state of equilibrium, to be able to stay with each other. This cup wants to lose energy to this air, and this air wants to lose energy to this wall and this wall. We are all attaining a state of equilibrium every moment, every now and then. If one system isn't going to help us here, let me look for a few more systems for you to understand better. You can take this chance to subscribe. So what I was saying is that this battery technology thing, in one way or another, it's not the best thing that we're going for, and we really have to come up with new ways of combating the climate change. This is true because if at the current state my country is struggling to sustain me with electrical power from non-renewable sources, so what will happen? Oh, I'm back. Suppose I take this cup, I bring it close to this cup, and I notice that these two are at the same temperature. I can conclude that these two cups are in thermoequilibrium with each other. And suppose I take this cup and bring them together, and again I notice no change in temperature. I can conclude that these two cups are in thermoequilibrium. And because I find out that that cup is in thermoequilibrium with this second cup, and this second cup is in thermoequilibrium with the first cup, I can easily conclude that that cup is also in thermoequilibrium with the first cup, right? This is called the zeroth law of thermodynamics, which states that if two systems are separately in thermoequilibrium with a third system, then the two systems are in thermoequilibrium with each other. Now you know. This is what justifies the use of a thermometer. When I dip a thermometer and I found that this is 37 degrees centigrade, and I dip it here and find that it is 37 degrees centigrade, I don't have to bring these two cups together and confirm that no heat is flowing in between them to conclude that they are in thermoequilibrium, because the thermometer, which is the third system, can simply confirm that to me. If they are in thermoequilibrium with the thermometer, then these two cups are in thermoequilibrium with each other. Thank you so much for watching. In our next video, we'll look at thermometry, the ideal gas laws, and have a brief introduction into the real gases. You can support this channel by subscribing and leaving a comment, liking this video, and sharing it to others. May you enjoy your time.